In the previous video, we were looking at deductive arguments, specifically how to evaluate deductive arguments. And in doing so, we examined a couple of concepts, validity and soundness. And we said that an argument is valid just in case if all the premises of the argument are true, then the conclusion must be true. Notice that's not saying that the premises are in fact true. It's just saying if they happen to be true, if they were true, then the conclusion would have to be true. It must be true. So another way of defining that, another way of putting it is to say that an argument is valid just in case it's impossible for the conclusion to be false and the premises to be true at the same time. Then we took a look at soundness, the concept of soundness. And an argument is sound just in case, one, it is a valid argument, and two, all of its premises do turn out to be true. So then we're taking a look at how the world really is. We're checking to see whether the premises are in fact true. If we get that condition and we get the condition that the argument is valid, then we know we have a sound argument. And sound arguments are good because then we know the conclusion is true. The conclusion has to be true in a sound argument. So now we're turning our attention to evaluating inductive arguments. And we're going to, again, take a look at a couple of concepts. In this case, we're going to take a look at strength and cogency. And we'll see that a strong argument is analogous to a valid argument. So the concept of strength here is going to be related, not exactly the same, but it's going to be closely related to the concept of validity. And likewise, cogency is going to be closely related or very like soundness, although it's not going to be the same. Once we're done evaluating inductive arguments, we're going to turn back and to look at deductive arguments in just a little bit more detail. And what we're going to do in that case is we're going to show how we can, if we're presented an invalid argument, we're going to take a look at how we can prove an argument to be invalid. Before turning our attention to inductive arguments and how to evaluate inductive arguments, I thought I would share this comic that I came across. So we've got our couple of turkeys here. First one says, "Hey, are you ready to go get fed by the farmer?" "Well, I don't know. I have a funny feeling that maybe we should just stay away from the farmer today." "Well, what are you talking about? The farmer is our friend. He gives us delicious grain every day. What are you so worried about?" It just seems like things might be different today for some reason. Look, it's simple inductive reasoning. Every day for the past several months, we go see the farmer, and every day he feeds us. Therefore, it's reasonable to infer that the same thing will happen today. And in fact, the inductive inference that he'll feed us is stronger today than it has been on any day before. Well, when you put it that way, all right, let's go get us some food. Happy Thanksgiving! And then the farmer kills the turkeys. And what's nice about this comic is the turkey gives a good inductive argument. We're going to see that this argument is in fact a strong argument, and if the if we allow there to be fictional facts, and if the turkey is telling the truth when giving the argument, and let's just say that he is, then not only is it a strong argument, but it's a cogent argument. But of course, inductive arguments are not like deductive arguments in that the truth gets guaranteed with 100% if we have a valid argument or a sound argument. Rather, we just have a greater probability of the conclusion being true than false. But that means there's going to be some times or some cases where the conclusion ends up being false, even though it was more likely to be true than false. All right, so let's turn our attention to these concepts of strength and cogency in more detail. All right, just to situate ourselves where we've been and where we're going, we started out in this course talking about arguments. We noted that they are a set of statements structured such that it reflects an inference. And of course, statements were the kinds of things that could be true or false. Arguments, though, are not the kinds of things that can be true or false. We get two kinds of arguments. We get deductive arguments and inductive arguments. And we started out looking at deductive arguments. And whereas statements are the kinds of things that can be true or false, propositions are the kinds of things that can be true or false, arguments, deductive arguments, are the kinds of things that can be valid or invalid. And as I was just saying, an argument is valid just in case if its premises are true, then its conclusion must be true. If it does not meet that definition, yet it's a deductive argument, it's a bad argument, and it's invalid. If it's invalid, it's automatically unsound, and that's because an argument is sound just in case it's valid, right? So if it's invalid, it fails to meet that condition. So an argument is sound just in case it's valid and has all true premises. So at this level, at the level of validity, we're really focusing on the inferential move. How strong is the inference? Does it get that guarantee or does it not get that guarantee? And as logicians, that's what we really end up being worried about for the most part. We're interested in that inferential move. Then once we take our logician hats off, then we become worried not just with whether the argument is truth-preserving, right, which is, again, a question of the inference, but then we get worried about whether the premises are in fact true, and as such, whether we should accept the conclusion. And if the argument is sound, we, on pain of irrationality, we better accept the conclusion. So we have a parallel structure then, now that we're turning to inductive arguments. So as we proceed to look at deductive arguments, as I've already mentioned, we'll look at these concepts of being a strong argument and being a cogent argument, or their opposites, weak and uncogent. And in the same way that validity and invalidity is worried about the inferential move and is worried about whether the argument is truth-preserving, same thing with strength and weakness. An argument is going to be strong just in case it's truth-preserving. And it's truth-preserving in a probabilistic sense, not this all or nothing sense. But it's got to get us over a certain percentage of likelihood. And if it does that, then it's a strong argument. If it fails to do that, it's a weak argument. And then if an argument is weak, it's automatically going to be uncogent. And that's because cogency requires, in the same way that soundness requires an argument to be valid, cogency requires an inductive argument to be strong and have all true premises. All right, so let's take a look at when an argument is inductively strong. An argument is inductively strong just in cases in which it is improbable that the conclusion is false, given that the premises are true. So again, the idea here behind this definition is that if the premises were true because of the supposed truth of the premises, it would make it such that the conclusion is more likely to be true than false. Okay? It's because of the premises. It's because of the informational content contained in the statements that make up the premises that's driving the conclusion to be more likely to be true than false. All right, so that's our definition of an inductively strong argument, but we need to add a provision, another provision to this, so or proviso. So it needs an argument, in order for it to be a strong argument, it needs to meet the total evidence requirement. So inductive arguments, presumably the reason why we get probabilistic results or reasoning out of inductive arguments is because we're not aware of all the factors. If we were God and we were omniscient and we knew everything, then everything, all of our reasoning, well, we might not even have to reason, I guess, but all of our reasoning would be deductive, because everything would, all of our knowledge would be guaranteed. It would be 100%. So even physical things like prediction, like if we predict how whether an asteroid is going to hit us or something of that sort, well, we wouldn't need to predict it. We would know, and we would know whether or not it was going to hit the Earth with 100% accuracy. But being that we are limited beings and we can't know everything, then we have to ascribe probability given the information that we do have available to us. And we can make arguments look strong if we leave out information in the premises of an argument that we give. So let's consider an example. Suppose I want to make the case to a friend that we should go to the beach. So suppose we're out in California or something, Florida or somewhere, and I'm trying to make the case that to my friend, hey, we really should go to the beach. It'd be a good idea. I want to maintain the conclusion that she'll have fun or enjoy it, or that it'd be a good idea if she and I were to go to the beach together. And I might say, well, look, it's going to be sunny out today, and you enjoy tanning, so you'll really like that aspect of the beach. And then I might give another premise. The waves are supposed to be really good today, so I know how much you love to surf. You're going to really enjoy the surfing out there today. It's going to be great. We'll be able to play some water ball or some I don't know, some volleyball and do some swimming and other water activities. But then suppose I leave out the information that I heard on the radio but she hadn't, that for the last couple of days, the beach that I want to take her to, that I want us to go to, has been infested with bull sharks, which are a particularly aggressive kind of shark. So there's just been all these sightings and there's been these attacks and whatnot, and I'm saying, hey, let's go swim there, and I don't give that information to her. Well, I'm failing to meet the total evidence requirement because I know that information, and that information is very relevant to whether it'd be a good idea for her to go to the beach with me, or whether she'll enjoy or have a fun time going to the beach with me. Right? If you get bitten by a shark, you're not going to have that great of a time. Or if the reason why she would really enjoy going to the beach is for the water activities and not just the sun tanning and playing volleyball, then that's also critical information with respect to how strong that argument's going to turn out to be. So we need to make sure that we disclose all the information that is relevant to the conclusion in order for it to be a strong argument. So how do we check for strength then? I'm going to give us 5 steps, more or less, depending how you want to divide this up. 5 steps that you can use when trying to decide whether an argument is strong or weak. So in the same way for validity, we ignore whether the premises are in reality true or false. We're going to ignore that when checking for strength. The question of whether the premises are in fact true don't come into play until we get to cogency. At this level, when we're checking for strength, we just care about examining the inference and whether the inferential move is good. So ignoring whether the premises are true, whether they are in reality true, we do pretend that the premises are true, which again is very similar to when we're checking for validity. So while we're pretending that the premises are true, then we want to ask ourselves, based on the information that those premises contain, is the conclusion more probable than not? So as a result of pretending that those premises are true, would that make the conclusion more likely to be true than false? And notice, what you're not worried about is whether the conclusion in isolation from the premises is probable or improbable. You might happen to know, irrespective of the information that you're given in the premises, you might know for other reasons that you're aware of that a conclusion is more probable than not. But that's not our question, because we want to know whether the premises are leading us to the conclusion. So we need to make sure to concentrate on whether the information contained in those premises is making it more likely to be true than false. Okay. All right. So fourth step, if we say yes, given that the premises are true, it is more probable than not, then we continue to the fifth step. If not, then we already know that the argument is weak. We don't need to go any further. But once we get to the fifth part, then we ask ourselves whether any pertinent information has been left out. So did this person leave out information that would give us pause about whether the conclusion was strong, so it's relevant to weakening the inference? And if the answer is yes, then the fact that we didn't give that information to the audience when we're aware of it, or when the person giving the argument is aware of it, then the argument is weak. But if not, if that information is not left out, then the argument is strong. So when does an argument get to be considered strong versus when it gets to be considered weak? Well, unlike deductive arguments, which are all or nothing, they're either 100% the conclusion does follow from the premises, or it 100% doesn't. With inductive arguments, because it's probabilistic, we end up having arguments with their strength coming in degrees. So I have this, I guess what is a speedometer here, that goes from 0 to 100. So let's ignore this part, and ignore this green part. I just want you to pay attention to the 0 to the 100. Now, of course, the 0 and the 100 itself are the all and nothing. If a conclusion doesn't follow at all, then we must be talking about a deductive argument, not an inductive argument. And if the conclusion follows with 100% level, then again we must be talking about a deductive argument. So all or nothing. Right? But between that, if the conclusion follows some percentage between that, between 0 and 100, now we're dealing with an inductive argument. And we say that from 50% and less is a weak argument. So clearly, there's levels of weakness. You know, if you have a 0.0001 chance of the conclusion following from the premises, then that's an especially weak argument. Whereas if you have, the conclusion is likely to follow 49.9997%, that's a relatively strong weak argument, but it still gets classified as weak. And if it's greater than this 50%, however tiny it is greater, as long as it's greater than this 50% mark, then that's a strong argument. And it's strong because if you get above this 50% mark, then the conclusion is more likely to be true than false. But if it's 50-50, then it's just as likely to be true as it is false. And if it's less than 50%, then it's more probable to be false than it is to be true. So you wouldn't want to accept the conclusion, those conclusions, right? That would be irrational. Well, why isn't it strong when it meets the 50%? Why does it have to be above 50%? Well, it's got to be above 50% because if think about it this way, if a 50% probability of accepting, so a conclusion ends up having a 50% probability of being true, suppose that was good enough level of probability to go ahead and accept that conclusion. The problem is it being false is also 50%. And if we're going to be consistent in our reasoning pattern, then it's just as good of an inference then to accept it being false. But now we accept the same thing to be true and false. But that's a contradiction, and contradictions can't happen. So that's why you have to get it above the 50%. That's the only case in which you have more reason to accept the conclusion than to not accept it. All right, let's apply the concept that we've been talking about here. Let's apply the concept strength. So we want to determine whether the argument here is a strong argument or whether it's a weak argument. So premise 1, our secretary is usually very pleasant. Premise 2, and she tends to smile when I say hello. Therefore, I conclude, she'll probably smile when I say hello to her this morning. So go ahead and pause the video. Take a little bit of time to determine whether you think this is a strong argument or a weak argument. If you said it was a strong argument, good. This is in fact a strong argument. So the conclusion is that the secretary is more likely than not to smile when I say hello to her this morning. Well, all the evidence that I've given, and assume for the moment that this is all the relevant information that I am aware of. So I meet the total evidence requirement. Okay, so what we know is she tends to smile when I say hello. And this tells me that more often than not, so greater than 50% of the time, she'll smile when I say hello. And not only that, she's very pleasant. And being very pleasant, you know, if you are a pleasant person, you're the kind of person who will tend to smile when somebody says hello to you. So given that evidence, it tells me that it's more than likely than not, that is, it's greater than a 50% chance that she'll smile when I say hello to her this morning. So this is a strong argument. So let's take a look at another argument, and we want to determine whether it's a strong argument or whether it's a weak argument. So our premise here is, of all the treatments that have come onto the market for fighting cancer, none has had any significant effect on a patient's life expectancy. So as a result, or in conclusion, the next treatment that comes onto the market is unlikely to have any significant effect on a patient's life expectancy. So again, pause the video and take a little bit of time to determine whether you think this is a strong argument or whether you think it is a weak argument. If you decided that it's a strong argument, good. This is also a strong argument. So if all the evidence that we have is that all of our past treatments never had any significant effect on a patient's life expectancy, Right? So if all the treatments in the past, none of them really worked, well, that's pretty strong evidence that the next one to come along is going to have the same types of problems. So it's a better bet, right? It's a greater than 50% chance likelihood that the next treatment that comes down the line will also be ineffective. It's not going to help people live longer. So that's why this is a strong argument. You may have been misled into thinking that it was a weak argument because this premise is factually false. It turns out that for many of the treatments for fighting cancer, they have had significant effect on prolonging people's lives. And they might not cure the cancer, that's true, right? But nonetheless, the treatments that we have available have been allowed us to enable people to live a much longer period of time than they had previously. So notice that in the same way, validity doesn't depend on whether the premises are actually true or false, in reality true or false. Neither does strength. Strength doesn't depend on whether the premises are in fact true or false. And they don't depend on whether the conclusion turns out to be true or false. It depends on whether the information contained in the premise actually suggests that the conclusion is more likely to be true than false. That is, it depends on whether the argument is truth-preserving. All right, so we looked at when an argument is a strong argument, an inductively strong argument. Now we want to know when inductive arguments are cogent. And an argument is inductively cogent just in case it is both strong and has all true premises. So again, in the same way that sound arguments have to meet two conditions, a sound argument has to be valid and have all true premises, we see that a cogent argument needs to be strong. That is, it needs to be truth-preserving. The conclusion needs to be more likely to follow than not to follow from the premises. And as a matter of fact, actually in the real world, as it were, the premises are true. They turn out to be true. You get those two conditions, then the argument in question is a cogent argument. So based on the definition of cogency, there's 3 steps that we need to take in order to determine whether an argument is cogent or whether it's uncogent. The first step actually is composed of a bunch of other smaller steps itself. We need to determine whether the argument is a strong argument or a weak argument. And if we determine that it's a weak argument, then we get to stop because we already know that it's uncogent. It doesn't have the truth-preserving characteristic of a good argument, so it's automatically an uncogent argument. But if it's strong, then we need to continue on and check some other aspects of the argument. Namely, we stop pretending that the premises are true, like we do when we're checking for strength. And now we ask ourselves the question whether in reality the premises are true. Are they actually true? And if they are, by our definition, then it's cogent. But if you find one premise that's false, then even though it's a strong argument, it's an uncogent argument. You still wouldn't accept the conclusion then. All right, so let's take the concept of cogency and apply it to an actual case. So we want to determine whether the following argument is cogent or whether it's uncogent. So it says Venus Williams, Kim Clijsters, and Roger Federer are all tennis champions. Each says, premise 2, each says that of all the stability running shoes on the market, the Brooks Adrenaline GTS 9 running shoe has the most cushioning. Therefore, out of all of the stability running shoes on the market, the Brooks Adrenaline GTS 9 has the most cushioning. So go ahead and pause the video for a moment and determine whether you think this is a cogent argument or whether it's an uncogent argument. All right, if you said this is an uncogent argument, you're correct. And you may have come to that conclusion for a couple of reasons. So premise one turns out to be true. All of these tennis players are in fact tennis champions. But since this is made up, this is false. It's not true that each of them say of the Brooks Adrenaline GTS 9 running shoe that it has the most cushioning. But suppose it was true in reality. It would still have been an uncogent argument because this is a weak argument. And most students are surprised when they find out that this is a weak argument. Well, notice, let me explain why it's weak. Notice that here we're all talking, who we're talking about are tennis champions. But we're not talking about tennis shoes. Surely our tennis champions are experts on most things with respect to tennis, right? And if we're trying to evaluate whether a claim is true, then we would defer to their expertise in tennis. But, you know, they're not Usain Bolt. So I don't care what they have to say about running shoes. They're not the right kind of expert. So this is an appeal to unqualified authority. They're not the right experts. Running shoes are not the kinds of things we should be trusting them about. So this does not follow more than a 50% chance based on Venus, Kim, and Roger telling us that this shoe has the most cushioning. So all in all, this is an uncogent argument. All right, so let's determine whether this argument is a cogent argument or an uncogent argument. So our first premise, every time I, and we're talking about me, every time I have been to first PA Med, my weight and blood pressure is taken before meeting the doctor. Turns out, and I'm just going to let you know, turns out that's true. I have visited first PA Med approximately 20 times. That's also turns out to be true. Therefore, at my next visit, my weight and blood pressure will be taken. So go ahead and take a little bit of time, pause the video, and determine whether you think this is a cogent argument or an uncogent argument. If you decided that this was a cogent argument, good. It is in fact a cogent argument. Why? Well, notice that every single time that I've gone to this doctor's office, first PA Med, it turns out that my weight and blood pressure is taken before meeting the doctor. And I have a pretty good sample of how many times I've gone. So I've gone about 20 times. So if for every single time that I've gone, I've had my weight, my blood pressure taken, very likely the next time it will also be my blood pressure and weight will be taken. So surely there's a greater than 50% chance that this will turn out, that the conclusion will turn out to be true, given premise 1 and premise 2. And not only is it so that makes it a strong argument, right? So this is a strong argument. that not only is it a strong argument, but the premises are in fact true. That meets both of our conditions for determining whether an argument is cogent or not. That meets the definition of cogency. Let's take a look at one more argument and determine whether it's a cogent argument or an uncogent argument before turning our attention to how we can prove the invalidity of deductive arguments. So in this argument, our premise states that a recent report indicated that the majority of speeding tickets issued in Missouri are issued to teenagers, and that it is likely that police officers catch only a third of all speeding teens. As a result, most Missouri teens drive over the speed limit. So from our first premise, we can know it's more likely than not, this argument purports, that most Missouri teens drive over the speed limit. So let me just stipulate that this is true. I don't know whether it's true or not, but let's say in reality it is in fact true. Go ahead and pause the video then and determine whether you think this is a cogent argument or an uncogent argument. All right, if you said that this is an uncogent argument, you're correct. And this is very tough to see. In fact, this is playing on a routine fallacy that we fall victim to when thinking about probability. It's called the base rate fallacy. So we take this first rate of the majority of speeding tickets being teenagers and then transfer to think that the majority of teens themselves must drive over the speed limit. But that's not the case. That doesn't have to follow. And we can illustrate why that's the case in this blank slide. So suppose we have all of our drivers, and this is supposed to represent all of the drivers, and suppose this represents the amount of drivers that drive over the speed limit. And this represents how many teenage drivers that we have. Notice that here we have teenagers who are driving over the speed limit, and they do in fact make up the majority of drivers who drive over the speed limit. But it does not follow from that at all that the majority of teens drive over the speed limit. Given the case that I've drawn up, the opposite. Right? The majority of our teens do not drive over the speed limit. So what that shows is, just given the information that we have in our argument, back in this slide. So given this information, it doesn't make it more probable that most Missouri teens drive over the speed limit. It's not enough information to tell us one way or the other whether it's more probable that most Missouri teens drive over the speed limit. So it's an uncogent argument. Even if we allow for this to be true, it's still not a strong argument, it's a weak argument, and therefore an uncogent argument. So now let's turn our attention to how we can go about proving invalid deductive arguments to be invalid. So how we can prove to somebody that an invalid deductive argument is in fact invalid. Proving arguments invalid. Specifically proving deductive arguments invalid, because inductive arguments aren't the kinds of arguments that can be invalid. Only deductive arguments can be invalid. And the way that we can prove some deductive arguments to be invalid is by presenting counterexamples. So we're going to turn our attention to what a counterexample is here shortly. But before doing so, we're going to have to cover the concepts of formal validity and the concept of substitution instance. And with those under our belts, then we'll be in a better position to understand counterexamples and to understand why it is that counterexamples demonstrate that an argument is invalid. So we turn our attention to that now. All right, so let's talk about formal validity. Notice I'm actually going to disagree with the author of the textbook. The author of the textbook maintains that all arguments, all valid arguments, are formally valid, and it's true that there's a way you can finagle that. It's true that for any valid argument, if you add premises, particular kinds of premises, you can get it to where it's valid because of its form. But really, it seems to me that some arguments are valid merely because of their content. So by the meaning of the contentful words as opposed to the formal words in a sentence can make an argument valid. So arguments from definition, for instance, seem to me to be a case of this where we see this a lot. Some arguments can be valid merely because of the form, merely because of the structure that the argument takes. And then there's the over-determining case of when the content and the structure would make the argument a valid argument. And as you'll see in this definition, that over-determining case, I'm just going to stipulate and make that count as an argument being formally valid. So for us, an argument is formally valid if and only if either one, the argument is valid because of its structure, not its content, or two, the argument is valid because of both its structure and content. So let's explore this a little bit more, what I mean by this. Let's see. So imagine we have an argument as simple as this. In some ways, you'll notice that this is nonsensical, doesn't have much meaning to it. If A, then B. If B, then C. Therefore, if A, then C. What I've done in this argument is I've kept what we call the form words. In this case, it's the if-then, because we're dealing with hypothetical syllogisms, so we're dealing with conditional statements. So I remove the content by just using these capital letters, which are just variables that just stand for any statement whatsoever. In this case, that's what they stand for any statement whatsoever. But the important thing then to note is for whatever statement we would let substitute for A, I've got to make sure to substitute that very same statement here. And same with B. So what we mean by that is substituting these uniformly. So if we put dog ate my homework for A here, this needs to be dog ate my homework as well. If this is the grass is green, then I better put the grass is green here. And if this is Socrates is mortal, then I had better put Socrates is mortal here. That would be substituting it uniformly. Now notice that all those statements I just gave, as far as our common understanding goes, they don't have much to do with anything. A dog eating homework doesn't have much to do with grass being green, and grass being green doesn't have much to do with Socrates being mortal or whatever I said. And, you know, any combination, they don't really seem to bear upon one another all that much in terms of their truth. But that doesn't matter. You could, if we substituted those in uniformly into that argument, we're going to end up with a valid argument. And that's because the structure itself is valid. If A really would get you B, so if A is going to end up guaranteeing B, so if A were to happen, I promise you you're going to get B. And if B happens, I promise you you're going to get C. It's got to be the case that if A happens, we're going to get C, right? Because A is going to lead to B, but we're also told that B leads to C. So A will get you to C. And it doesn't matter what statements we put in for A, B, or C. Choose whatever your favorite statements are. As long as you substitute them in uniformly, you're going to end up with a valid argument. You might have a whole bunch of false premises and you might have a false conclusion, but you're still going to have a valid argument. Now, this argument then, any argument that we substitute in here is going to satisfy this definition. It's going to be formally valid. And that's because the structure is going to guarantee the validity of this argument. And we could even make a substitution where the content would guarantee that we have a valid argument. So take the conclusion, if A then B. Suppose we substituted in for A vixen. And if you know what the definition of a vixen is, it's a female fox. So then if we let C be female fox, then we would have our conclusion saying if, well, let's say we actually need to substitute a statement, not just a word. So let's say if Sally is a vixen, then Sally is a female fox. This conclusion then would necessarily be true by the meaning of vixen and by the meaning of female fox, because they are synonymous with one another. If Sally is one of them, Sally's got to be the other one. And that means, given that content, you could never have all true premises and a false conclusion. That is this, which means you could never violate the definition of validity that we have, right? Because a valid argument is one that if the premises are true, then the conclusion must be true. Or the other way of saying that was, it's an argument which is impossible to have a false conclusion and all true premises. Well, it is impossible to have a false conclusion and all true premises if the conclusion was, if Sally is a vixen, then Sally is a female fox, because for the reason that that conclusion can never be false. There's not an instance that it can be false. So it satisfies the definition of validity. But that's going to be because of, in this case, the content, yet also the structure, whatever we ended up substituting in for B, the structure is also going to be, let's see, here's the structure, is also going to make it such that the argument has to be valid. And that's why I have this second case here. This is an overdetermined case because it's valid for or at least there's two reasons we can point to explain why it's valid. But since it includes the structure or the form, I'm going to count it as part of my definition for when an argument is formally valid. Now that we understand formal validity, we want to turn our attention to the concept of substitution instance. And I've already hinted at this concept to some degree in talking about formal validity. And that's because in understanding a substitution instance, one of the things we need to know or be able to do is to identify the form or the structure or the pattern of reasoning that is taking place in the argument. And the way that we do that is we identify the form words of an argument. So the example of form words when it comes to hypothetical syllogisms is the if-then statements. For categorical syllogisms, there's many of them. There are a few anyways. So all, every, no, some, are, and are not are the form words. And then the content that you find in between those form words. So for instance, let's say no lizards are, let's say no snakes are mammals, for instance. We have no and are as being our form words. Our content words are going to be snakes and mammals. So what we would do is we keep those form words. So in this case, we would keep no and we would keep are, and then we would replace the content with letters. So if we used snakes and mammals, the best letters probably would be no, S, R, M. So what we've done is we've taken out the meaning of the subject matter that we're talking about. And anytime that we see, in the example that I've just given, anytime we see snake throughout the argument, we need to be sure to replace it with an S. And anytime we see mammal, we need to make sure to replace it with M. And that's making this replacement, that substitution, well, that's making this replacement uniform. So we replace the content with letters uniformly. Okay, so if we do that with this example that I have here, this argument, which says all dogs go to heaven, all things that go to heaven are good, therefore all dogs are good. So our form words in this case is all. Let's use D for dogs. So all D are H. So all dogs are things that go to heaven. And that's premise 1. Premise 2. All things that go to heaven are things that are good. And our conclusion, all dogs are things that are good. This identifies the form of this argument. And it does so because it leaves the words that indicate the reasoning pattern, the structure of the argument, and it takes away the content. Then the next step to get a substitution instance, now that we have the form, we get a substitution instance simply by replacing these letters with content that's different than what we had, than what we originally started out with. So let's say D, we can make that snakes. So all snakes are things that, let's say, go to hell. Why not? Since dogs go to heaven. So all things that go to hell, and let's go ahead and say are bad things. They are bad. Therefore, all snakes are bad. This argument that we're left with is a substitution instance of this argument. And notice that wherever there was a D, I made sure to put snakes, right? Because that corresponds with this D and this D. And then every time there was an H, every place in which there was an H, I made sure to replace with hell or things that go to hell, since that's what is really being talked about. All right, so that corresponds with these H's. And every time we saw a G, I made sure in the corresponding premise and conclusion to use bad, to talk about bad things. And that's, again, I know I'm kind of beating this point with a dead horse, or beating this beating this point like a dead horse. That's what we mean by uniformly. That's what we mean by uniformly. So this is an example of how you go from an argument to making a substitution instance of it. First, you identify the form. Then you substitute in different content, and then that gives you the substitution instance of your original argument. So now that we understand formal validity and we understand substitution instances, we can now turn our attention to counterexamples and understand what a counterexample is. So I'm going to define a counterexample in the following way. So argument X is a counterexample of argument Y if and only if it meets the following three conditions. 1, it is a substitution instance of Y. 2, X's premises are true, that is, in reality, actually, factually, are in fact true, and X's conclusion is false, that is, actually, really, in reality, is false. So it's got to meet those three conditions. This needs to be a substitution instance. What that's going to do is guarantee that the counterexample has the same form as the original argument, the argument that we want to prove invalid. Then X's premises need to be true and the conclusion needs to be false. Well, why those latter two conditions? Why 2 and 3? Well, think about the definition that we've been using for a valid argument. An argument is valid if and only if all the premises are true, then the conclusion must be true. But if we can construct a counterexample, we end up with an argument whose premises are true, but its conclusion is false. So notice that violates the definition of validity. Validity says, so if an argument's valid, then if its premises are true, that guarantees that the conclusion will be true. Well, if an argument really does factually have true premises but a false conclusion, notice its true premises did not guarantee the truth of its conclusion because its conclusion is, as a factual matter, false. It cannot be a valid argument. Now, since we use counterexamples to show that arguments are formally invalid, then what condition 1 does for us is it keeps the very same form or structure. So now we know that we have an invalid argument because of condition 2 and 3 being fulfilled, and that violates our definition of validity. But now we know that it can't be that its structure guarantees validity, right? And if the structure is the same from one argument to the other, then it doesn't matter which argument you provide. It wasn't doing the work to making the argument valid. So it either needed to be its content alone, or it's just invalid, or it's an invalid argument. Now, what I am going to agree with the book on is that arguments that are valid solely because of their content are pretty rare. And not only are they rare, but in some ways they're logically less interesting than arguments that are formally valid. There's a lot more to analyze objectively speaking once you get a grasp that arguments can be valid because of their structure, because that puts us in a position then to develop methods to figure out whether a structure is good or bad. So that puts us insofar as we're logicians and we care about truth preservation, that's a more interesting subject matter because there's more material there for us to work with. Okay, so that's why counterexamples work. That's why they prove to somebody that their argument is invalid, is formally invalid. And basically what I was trying to say is if it's formally invalid, we're just going to accept it to be an altogether invalid argument for our purposes because of the rarity of arguments that are valid because of its content alone. All right, so let's look at this in action then. We have the argument up here. All humans are mortal. Socrates was mortal. Therefore, Socrates was a human. So what do? We give ourselves a substitution instance down here. Wherever we see humans, we give ourselves an H. And wherever we see mortal, we give ourselves an M in the same place. And wherever we see Socrates, we give ourselves an S, and we keep all our form words the same. Let premise 1, when I say all humans are mortal, and therefore this premise 1 here, let that, all humans, let that capture present, past, and future humans. Okay. So now we need to make a substitution instance in which we end up with true premises. So we need to make these true, but a false conclusion. So we need to make the conclusion false. And if we do that, then we'll have satisfied this definition, which means we'll have a counterexample, which means we'll have proven this argument to be an invalid argument. So it's best practice to figure out a conclusion that's going to be false. So we could say that Babe Ruth was a hockey player because Babe Ruth was not a hockey player. So let's do that. Let's get a substitution instance going on over here. We'll have two premises and the conclusion, which is what we want to focus on right now. And we said Babe Ruth was a hockey player. So that's false. It's false that Babe Ruth was a hockey player. And then we could say that all hockey players, and then for our M, substitute in athletes. And we could even make that all professional hockey players are athletes, just in case you're picky about whether pee-wee hockey players should be counted as athletes. But surely all professional hockey players are athletes. And then we can say that Babe Ruth was an athlete. Maybe you would even be nitpicky about whether Babe Ruth was an athlete. You've got pictures of him being, not in shape and everything back then. But I think, given how good he was at baseball, that we should probably count him as an athlete. And if that's the case, then notice that our premises are true, because all hockey players are athletes. Babe Ruth was an athlete, yet Babe Ruth was not a hockey player, so that's false. And wherever we have the S's, which is what I substitute in for Babe Ruth, I've got Babe Ruth in the exact same place. Wherever we have athlete, wherever we have M's rather, we have athletes. And wherever we have the H's, we have hockey players. And so this is a substitution instance. So this is a substitution instance. It satisfies our first criterion. All of its premises are true. That satisfies our second criterion. The conclusion is false. So that satisfies our third criterion. And it needed to satisfy all of those. So since it satisfied all of them, it is in fact a counterexample, and it proves this original argument to be formally invalid. And so for our purposes, since we're not going to deal with the cases in which we're not going to focus on cases in which the content is what determines validity, we're just not only are we going to allow this to be formally invalid, but we're just going to maintain that it's invalid wholesale. So this is an invalid argument. Notice it's important to note, and you'll have a chance to practice this in your homework or the exercises. You could have a substitution instance which then has true premises and a true conclusion, and that would not be a counterexample. It's got to satisfy all three of these criteria.